So this lesson is going to cover the difference between an atom and an ion. So our need to know, the first thing is we need to obviously be able to describe the difference between an atom and an ion. We need to know how to determine if an atom will gain or lose electrons, and as a result of that, how does gaining or losing electrons change the charge of the resulting ion? How to represent ions using Bohr diagrams, and how to represent ions using what's called a Lewis dot diagram. And finally, we need to know what type of ions metals typically form and what type of ions non-metals typically form. So as a quick refresher, we've been talking a little bit about the elements on the periodic table so far, and we have to remember that they are all what are called atoms. So each element on the periodic table is an atom, which means it's in the smallest form of matter possible. It can't be divided any smaller. Atoms always have what's called a neutral charge, which means they have an overall charge of 0, and that's because they have the same number of protons and the same number of electrons. So what that means is if I have let's say two protons, so two positive charges, and two electrons, so two negative charges, the +2 and the -2 equal to an overall net charge of 0. So what's an ion in the first place? Well, an ion is what results if an atom gains or loses an electron. In an ion, the number of protons does not change. So if we have an ion of sodium and an atom of sodium, they have the same number of protons. But what will change between the atom and the ion is the number of electrons. And that's important because the number of electrons is going to change the charge. So why would an atom want to become an ion in the first place? Well, all atoms want to have a full valence shell. So remember, the valence shell is the outer shell in our Bohr diagram, and so atoms always want to have that completely full. They can achieve this then by either gaining or losing electrons. If an atom loses electrons, so we're taking away negative charges, that atom is become more positively charged, and so we call that a cation. If, however, an atom gains electrons, so it's taking on more negative charge, it's going to become more negatively charged, and it's called an anion. So atoms always take the easy way out, kind of like you guys as students. Students are always looking for the easiest option when it comes to completing an assignment. So if we look at sodium, the goal of sodium, remember, is to have a full valence shell. So right now we have this one valence electron by itself, and so sodium has two different options to get that valence shell. What it can do is sodium can either lose this electron, so it can get rid of that electron. If I got rid of this electron, I would have a full shell of 8 electrons, and that would be the outer shell, because if I took away this electron, I would only have this shell left on the outside, so that would have full set of 8 electrons. Or it could take on 7 more electrons to fill this shell that it currently has. So it could either take on 7 or lose 1. So remember that anything we do requires energy and it takes work. So as a student, if you're looking for the easiest way to do something, would you go through the energy of finding and taking on 7 electrons so that you can have a full shell? Or would you just simply remove 1? Well, the option there is pretty obvious. Option A is the easiest option. So what that means is that if we have sodium, a sodium atom, when sodium becomes an ion, it's going to lose 1 electron. It won't gain 7 because that's just too much work, and so since we want the easiest way out, a sodium ion will lose 1 electron. So what we're going to do is we are going to take a look at the difference between a sodium atom. So here's our Bohr diagram for the sodium atom. Remember, this has a neutral charge because we have the same number of protons as we do electrons, so 11 and 11. But we're going to draw the sodium ion. So here we have, again, this is the atom. So this would be the normal Bohr-Rutherford diagram that we would draw. We would get this information, remember, from the periodic table. So 11 is the atomic number. The number of neutrons would be the atomic mass. Subtract the atomic number, and the number of electrons is always the same as the number of protons. So we know how to draw these Bohr diagrams already. What we're going to do next is draw a sodium ion. So in our ion, the protons are always going to be the same. So that means that the neutrons are also the same. The atomic mass hasn't really changed. So we have 11 protons and 12 neutrons. Because we have the same number of protons and neutrons, the atomic mass hasn't really changed. Because electrons don't really weigh that much, so by gaining or losing electrons, the mass won't really change. Next thing we need to do is draw our electrons. So normally the sodium atom has 11 electrons. That's because there's 11 protons, so we need 11 electrons to have a overall neutral charge. In our ion, remember that we said the easiest way for sodium to have a full valence shell is if it just gets rid of one electron. That's the easiest way to get a full outer shell. So we're going to draw what that would look like. Our first shell would have 2, next shell would have 8. So instead of having 11 electrons, we now have 10 because we've gotten rid of this one on the outside here. So now we have an ion, and in our ion we have 10 electrons, leaving us with a full valence shell. So when we draw our Bohr-Rutherford diagram for an ion, we have to put these brackets around it. This tells me that it's an ion, meaning that it has gained or lost electrons. In this case, we lost 1 electron. So if we lose an electron, we're losing negative charge. So I'm taking away negative charge, so I become more positive charged. And so the overall charge of a sodium ion is +1 because it has lost an electron. So if you recall then, since our sodium ion has lost electrons, it has become positively charged and we call it a cation. So again, here we go. That's what our sodium ion would look like. Number of protons and neutrons stayed the same. And we've just drawn this without the other shell because we've gotten rid of this electron over here. So we've gotten rid of this electron, and we have now a charge of +1. So that's how we would draw it with a Bohr diagram. Next we're gonna talk about how to draw Lewis dot diagrams. So a Lewis dot diagram shows only the valence electrons in an atom or ion. So if we take a look then at sodium once again, if you remember our sodium atom, so we're going to do the atom first, the sodium atom normally has 1 valence electron. If, however, we drew the sodium ion, remember that it lost that 1 electron so that it would have a full valence shell. Kind of like the Bohr diagrams, we have to put brackets around this to show that we are drawing an ion. And now, since we've lost 1 electron, we've become more positively charged. So now we have a charge of +1. So that is it. That's a Lewis dot diagram. I just write the symbol for the element and draw only the valence electrons. So if I had 6 valence electrons, I would put 6. And that's it. Similar to the Bohr diagrams, we put these square brackets around the ion, and we also indicate the charge. So once again, we have our sodium atom, 1 valence electron, and the ion, which has our full shell because we've lost this electron, and now we have a full shell and a charge of +1. So our Lewis dot diagram only show the valence electrons of an atom or an ion. If I were to show you these two pictures, you could tell right away which one was an ion, because you just have to look for 2 things. If you see these square brackets and you see a charge, you know you have an ion. If there's no square brackets and no charge, then it's an atom. I'll show you first how to fill this out, and that way you know enough to get started. So first thing we need to do is have our periodic table ready so that we can refer back to that, and we have to have our worksheet. So if we look at lithium, we want to draw a lithium atom. First thing we need to do is figure out, is lithium a metal or a non-metal? Well, where's lithium on the periodic table? It's over here. And what we know is that this side over here is where all the metals are. So lithium is a metal. And it says to draw a Bohr-Rutherford diagram for each of the atoms and the ions. So to start our Bohr diagram, we need to know the number of protons, electrons, and neutrons. Number of protons is equal to the atomic number, which is 3. The neutrons is the atomic mass, which is going to be 7, take away 3, which is 4. And the number of electrons is the same as the number of protons. We draw the nucleus, draw our first shell. We have 2 electrons, the next shell we have 1. So that gives us now a total of 3 electrons, and that matches what we have over here. So there we go, we've drawn the Bohr diagram for a lithium atom. We know it's the atom because the protons, we have the same number of protons as we do electrons. If I were to come over here and draw the ion, I have to consider my 2 options. So the 2 options for lithium is we could, if we look at our valence shell, we could get rid of this electron. So we could lose 1 electron, or we could gain 7. Which one of these takes less work? Losing 1 or gaining 7? The easier option here is to lose 1. And so when we draw our lithium ion, we need to do this option right here. You will not see this option because it takes too much energy. I take you through thinking about the 2 options because it's always important to remember, how do I know if it's going to lose or gain? You know how to figure out if it will lose or gain electrons based on what one requires less work. So just think about which option takes less work. So it's easier to lose 1 than it is to gain 7. So we're going to use this information here to draw our ion. Our ion has the same number of protons, same number of neutrons. That doesn't change. The only thing that changes here are the number of electrons. So instead of having, so we still have 3 protons, 4 neutrons. We now, however, since we lose 1 electron, we only have 2. 1, 2. Notice now that we have a full valence shell. So the difference here is since we've lost our electrons, we only have 2 electrons. So we lost that 1 on the outside. But that's good because now we have a full valence shell, so lithium is happy. I am missing one thing, however. I need my square brackets. And I lost 1 electron since I lost a negative charge. So I lost a negative charge, I became more positive. So that's the first one. Let's do the next one together, and then we will take a break for you to work on the rest on your own. So nitrogen is the next one. We had pull the nitrogen up on our periodic table. It's on the right side over here, so we know that it is a non-metal. Let's figure out the number of protons, neutrons, and electrons. Our protons are the atomic number, so we have 7 protons. Number of neutrons will be the atomic mass minus the atomic number, so 14, take away 7. Oops, I put that in the wrong spot. And our number of electrons is the same as the number of protons. We'll draw the nucleus. And then we will place our electrons. First shell has 2. Next shell, we need to fill 7 electrons, so that we already have 2, so we're going to do 3, 4, 5, 6, and 7. So right now we have 1, 2, 3, 4, 5 valence electrons. Next, we're going to go through our options. What options does nitrogen have to gain a full shell? It has 5 in the outside, so we can either gain 3, and that will give us a full shell, or if we lose 5, that will give us a full shell. So if we lose all 5 of these, let's just highlight our valence electrons. So if I lose all 5 of those, that will leave me with this shell in the middle here, which will become the valence shell, and it will be full. So I could lose 5. Or I could fill the rest of this shell with 3. Well, it's actually easier to gain 3 than it is to lose 5. So we know that our ion is going to gain 3 electrons. And this option right here requires too much energy, so we're not going to bother with it. Let's draw our ion. Number of protons. Number of protons stays the same. Number of neutrons will stay the same, but our electrons will change. If I have 7 over here, or sorry, if I have 5 over here, and I gain 3, I'm going to get a total of 8. So that's the only thing that changes is the number. And then start filling our shells. First shell has 2 electrons. Next shell sorry, I did my math wrong here. The atom for nitrogen has 7 electrons. So if I gain 3, I'm actually going to get not 8, but 10. Just correct that first. So my first shell has 2. Next shell, if I was drawing a normal nitrogen atom, the next shell would only have 5. So I would normally I would be finished here if I was drawing a nitrogen atom. But because I'm drawing the ion, I have to gain 3 electrons. So 1, 2, and 3. Notice my full valence shell. I have 8 valence electrons. Put my square brackets in because it's an ion, so it needs brackets around it. And I've gained 3 electrons. I've taken on more negative charge because I've added these electrons. So I have a negative charge of -3. And that's my nitrogen ion. You're going to go ahead and finish the rest on your own. Make sure you remember that when you get to this second page here, you're actually going to be drawing the Lewis dot diagrams instead of a Bohr diagram, so it's a little bit less work for you.